Alright, hey guys. So for this little video here, I'm going to be going over how to do dilutions. You had one example in the notes that I had given all the work for, but the others were just for examples for you to work through, so I'm just going to go through how to do those. Just before we do that though, quickly review here. For dilutions, you're using this formula here, C1V1 equals C2V2, okay? And in this case, C1 is your starting concentration. So typically speaking, with a dilution, you have a stock solution that is very concentrated, and you're going to dilute it down to something that's easier to work with and safer and possibly just what you need for your lab. Okay? V1 is your starting volume. Okay? That's how much of the stock solution you need. So generally speaking, you need just a little bit of the stock solution. So you have a small volume of it, and then you add in water to get to the desired concentration. And you do this even so probably in just everyday things too, like if you are cooking or if you buy like the concentrated juice and you have like the frozen one, you need to add water in it just to dilute it down so it's drinkable and not just a big sugary leftover stuff. Okay. C2 is the end concentration, so that's what you are ending up with, like how dilute you want it to be. And then the last thing there is the end volume, and that is the total volume that you're going to have after you add in the water. Okay, so this isn't how much water we added, this is the total volume of the stock plus the water that we added in to make it dilute. Okay, so the first example I'd already done in the notes, so I'm going to go ahead to the second one here, and in this case we actually require 100 milliliters of a 1.50 molar sulfuric acid solution. Okay, we have a stock solution that starts at 18.0 molarity of the sulfuric acid. How much of the stock solution do we need? So right now we are starting with V2. That's the total volume that we need at the end. We have C2. We want to have dilute or what the concentration is going to be at the end. And we have C1. So again, just to write it a little bit more clear, C1 is 18.0 molar. V1, we don't know. C2 is 1.50 m, and V2 is 100 milliliters. Okay, now just going back a moment, remember that with volume, we don't actually need to change it to liters like we did with this formula. C equals N over V. That should have been in liters. In this case, we don't really worry too much about that, as long as you are aware that your final answer, the V1 will also be in milliliters. So if you were to need to calculate something later with that, then you might have to, but we don't really get into that in grade 11, so not too much to worry about there. So let's just plug in our numbers now. 18.0 m, times V1 is equal to 1.50 m times 100 ml. Now, whether you want to simplify one side first and then divide or rearrange things first doesn't really matter. I'm just going to show out all of the work. I'm going to simplify the right first. As it's new, I don't really want to get into how to skipping too many steps. Okay, so 1.5 times 100 is 150.0 ml. Units not too crazy important here, they're all going to cancel out at the end. So now we're going to divide by 18. Okay. So they cancel out, great. Those are going to cancel out. So 150 divided by 18 is, get my calculator out, 150. So V1 is equal to 8.33 milliliters. Okay, so that is how much of the stock solution we are going to need. Now, some questions might ask how much water you need to add to this then, so that would just be finding the difference. So our total end volume is 100 ml, so that's V2 is 100 ml. So that includes the stock plus water. So if we wanted to know how much water we had to add, we would just subtract this amount from our total end volume. Okay, this question doesn't do it. Not going to worry about it then. So we'll see maybe in the next one it does do that. So example 3 says, what is the final solution or concentration of a solution when adding 250 ml to a 50 ml of a 12 molar stock solution? Okay, so in this case we're actually finding C2, so it's slightly different, same formula though, but it doesn't really matter. Okay, another thing to be aware of is that we are adding 250 milliliters, so it doesn't outright tell you this, but V2 then is going to be 300. Okay, our V1 right here, it's 50 ml, that's what we're starting with, and then we also got C1 here. So C1 is 12 molars. V1, we've taken 50 mLs of this. C2, we don't really know. And V2, okay, we are adding 250 mLs of water here to this. Okay, so your V2 is actually going to be 300 mLs. Okay, so we are actually now, like the question kind of mentions there, as a hint, you are looking for C2. May not always tell you that, but just so you are aware. Okay, so now let's plug in all our numbers. C1 V1 equals C2 V2. So C1 is 12.0. And again, you don't have to write the units, it's just a habit I have. V1 is 50 ml. C2 is our unknown, and our final volume is 300 milliliters. Okay, so again, let's simplify one side. In this case, let's simplify the one that we actually can, which is this side. So we do 12 times 50, which gives us 600 equals C2 over 300. And then, again, divide by 300, that cancels out. Okay. Units are then going to cancel, and what we are left with then, this one actually works out nice. It doesn't always do that when I make up questions, which is nice. And we get a 2 molar solution C2. Okay, so that means the concentration of the solution after we dilute it by adding in 250 milliliters of water means we're going to have now a 2 molar solution. Okay, doesn't actually matter what the solution is in this case. It's going to work out the same. Now again, could we ask questions later about calculating the moles? Sure, of course. But in this case, don't need to. We got the final concentration. It's 2 molars. Great. Done. Okay. The last question now is this one I've added in. This is just one extra on top of the ones that were in the notes previously. So you may want to write this one down on a piece of paper or on the notes that you were taking before. It's just one extra thing just to try. Okay. So in this case, we got a concentrated, another 12 molar solution of nitric acid. So we got C1. We need a 300 milliliters of a 1 molar solution. So we got V2, and we also have C2. Oops, a little bit more. All right, that means V1 is unknown. So in this case, it says how much of this concentrated solution do you need? And there's one extra thing here, how much water is being added. Okay, so let's do the first part first. Let's tackle this one. How much concentrated solution do you need? What is V1? That part, easy enough. So, again, I'm just going to write it out. I'm going to write it out for you. So these are the numbers that we have to start. And we want a 1 molar solution. And we need 300 milliliters of it. Okay, so it's going to go straight to plugging in the numbers in this case, just because we've done a couple now. So we have 12 molars times V1 equals 1 molar times 300 ml. Okay, V1 then, I'm just, again, skipping a step here. Obviously 1 times 300 is 300, so I'm going to go straight to this. Okay, and so 300 divided by 12 will be 25. So we need 25 milliliters of our stock solution to make 300 milliliters of a 1 molar solution. Okay, so we're taking 25 milliliters of this. Oops. We're taking 25 milliliters of this guy, and we're going to add a whole bunch of water into it so that we can make the 300 milliliters of that 1 molar solution. Now, the second part of the question right here is saying how much water is being added. So this is quite simple to do. All we really need to do then is take the final volume that we require, and do it in purple so it matches. We are then going to subtract how much of the stock solution we used, which was 25 milliliters. So that means we had to add 275 milliliters of water to the stock to make our 300 milliliters of solution. Okay, so that means I'm just going to write it up here, running out of space. Nope, wanted to erase that. So 250 milliliters of H2O is added. Hooray! We did it! Okay, so that's everything there. That's basically it for dilutions. They're really not too bad. Again, it's not a whole lot different in terms of the math as it is from the gas laws. You have the starting amount, you have a starting quantity, we make a change. How does that impact the other variable in question here? So the math is actually very similar to what we've already seen in the gas laws. It's just identifying which one is C1, V1, C2, and V2, and then plugging in those numbers and going from there. Okay, so that's it for this little mini lesson here. If you have questions, again, feel free to ask and send me a message, and then I can do some more with you. But in our next class, I can quickly go over some if you need. But otherwise, we'll be moving on to our final unit, which is organic chem. So see you all then. Again, let me know if you have questions. See ya.